Hi, my name is Amrita Kosanam and I'm a junior at Tompkins High School in Texas. I'm going to be showing another group testing method called a row and column testing. In my previous videos, I've shown other group testing methods such as the binary method and the Dorfman method. So before I get into how the row column method works, I would like to just thank Dr. Krishna Narayanan from A&M University for getting me involved on this project and providing me with the opportunity to learn about and show different group testing methods. I would also like to thank Dr. Sangeeta Khare and Dr. Gokulam Kupan for providing their help with the concept and the project as well. In this row and column test, we have 25 samples, 2 of which will be infected. To simulate an infected sample, we will be using a glucose solution and water for a non-infective sample. In past group testing videos, I have shown the methods with one infected person, but in this group testing method, I'm going to show 2 infected samples, each with different glucose concentrations to simulate 2 patients with different viral shedding. In this experiment, sample numbers 8 and 16 will be the infected sample. Sample 8 will have a higher concentration level of glucose than 16, and we will see this difference through the test strips. In this group testing method, I will arrange the 25 samples in a 5 by 5 array. Samples 1 through 5 will be in row 1, 6 through 10 in row 2, and so on. To do the group test, I will be taking samples from combined pools made of all of the samples within a row and all of the samples within a column, and this will happen for all rows and columns. So to test all of these 25 samples, we're only going to need 10 tests. Alright, so now we're going to be adding the respective contents into all of the test tubes. So as I said before, 8 and 16 are going to get the glucose concentrations and the rest of the test tubes will be filled with water. Alright, so I'm done filling water for all of the non-infected samples, but now I'm going to fill the glucose concentrations for sample 8 and sample 16. I'm going to be using different syringes to avoid any possibilities of cross-contamination. So now we've filled all of the samples with their respective solutions, 23 with water and 8 and 16 with different glucose solutions. Now we're going to be doing the testing on pooling of each of the rows. Alright, so I've changed my setup and now I have all of the test tubes ready to create my pooled tests. So I have the test tubes for all of my rows ready right here and my test tubes for all of my columns ready right here. So samples 1 through 5 are going to go in test tube 31, 6 through 10 in 32, and so on. And the column tests are going to go in test tubes 41 through 45. So all of our pool tests are ready. We have the row test ready and we have the column test ready. Now we're ready to test using test strips. When we do these tests, you're going to see different shades on the glucose test strips that we used. And this is going to be based on the concentration of glucose within the solution that we're measuring. If the solution has no concentration or no presence of glucose, then it'll stay yellow. But if the solution does have glucose in it, it'll be some shade of green. It'll be lighter if there's less glucose, and it can go all the way to very dark green if there's a lot of glucose. And the different concentrations that we used in our 2 infected samples simulate the different viral loads that a patient may have. So we're going to be able to see this in the color of the tests. Okay, so we have our results here. I'm gonna first rule out the rows and columns that we know are not infected based on these samples that stayed yellow. So that is column 2, column 4, column 5, and then row 1, row 3, and row 5. Now, let's look at where these infected samples match up. We have, well, sample 8, we have sample 18, we have sample 6, and we have sample 16. Now, we see here 4 combinations, but in the beginning, we only had 2 infected samples. So we're going to look at these samples now. We have this darker and darker test strip, and these match up, meaning when you test a sample, the colors of the test strips have to match up. If they're not cohesive, that doesn't make sense because a sample cannot produce a dark test strip as well as a light test strip. The concentration will be the same throughout the entire sample. So, dark and dark, that means 8 is it's a correct sample. It is an infected sample. We have this dark and light, however. This cannot be possible as stated earlier, so sample 6 is not a real infected sample. Now we have a light and a dark, and these cannot be possible as stated before, so sample 18 is not a real infected sample. Now we have a lighter sample and a lighter sample. This is sample 16, and we know this makes sense. So sample 16 is another infected sample. So as you can see, this method is actually very interesting and very effective because we had 2 infected samples, but when we took our strips and arranged them, we found that there were actually 4 possible combinations. However, we were able to rule out the two samples that weren't really infected by looking at which combinations of test strips can work. So dark and dark can work, light and light can work, and which ones can't work. So things that have contrasting gradients will not work. So it's a really interesting method. Thank you guys for watching this demonstration of the row and column experiment, and it was definitely a very interesting experiment, and I hope you liked it as much as I did. As I end this video, I would again like to thank Dr. Krishna Narayanan from A&M University for providing me with the opportunity to do this project and helping me learn more about group testing. I would also like to thank Dr. Sangeeta Kare and Dr. Gokulan Kopan for providing their help with the concept and the project as well. Thanks for watching.